Okay, so on this episode of How Do We Wire It, this is an example of a Thermopile standing pilot furnace. Now, what's the difference between a thermopile and a thermocouple? Well, a thermocouple is a much smaller pilot flame sensing device that usually maybe puts out somewhere around 30 millivolts of electricity to energize the pilot valve inside the gas valve. Your thermopiles operate off of the very same principle as a thermocouple. They are just slightly bigger. And when they're slightly bigger, they're able to put out much higher millivolts. Thermopiles can range anywhere from 30 millivolts and above. They can go up as high as probably about 350 millivolts. So with this diagram here, we're going to focus on how do we wire this type of equipment. Now, looking at the screen, you can kind of see that there's some stuff that's missing. One of them, preferably, is the transformer. I'm not operating off of any sort of 24 volts in this particular type of system. I am actually using the Thermopile to energize my gas valve. The only thing that is going to be wired with any sort of line voltage is going to be my blower. So let's get started. How do we wire this? Well, it's very simple. Okay, up here I have my L1 and my neutral. I got a thermostat, I got my thermopile, I got my gas valve basically right here. I got my millivolt pilot valve, and I have my main valve, which is also powered off of my millivolts. I have a high limit switch, I got a fan limit switch, and I got a blower. So really all we're doing with this type of wiring is I'm taking 120 volts and I'm going to just simply wire my blower motor. So I'm coming out of my L1 and I'm going to power up my fan limit side of my circuit. Okay? Just like this. I'm going to come out of my fan limit switch down into my blower. Come out of my blower, and I'm going to go right back to my neutral. Just like so. So at about 140, maybe 150 degrees, that switch was going to close when my furnace heats up, turning on my blower. Everything else is operated off of my millivolts. So how do I wire this? Well, here's my thermopile right here. My thermopile is going to generate its own electricity when my pilot valve is lit. Now remember, in a standing pilot furnace, that pilot has to be manually lit with a match, grow lighter, something, so that you can establish a flame. It does not happen on its own unless you have some sort of ignition sequence, some sort of ignition module, a spark, hot surface, something like that. But in many cases, when you are dealing with a thermocouple or a thermopile type of furnace, that pilot needs to be manually lit. So once that pilot is lit, the flame of that pilot will begin to heat up my thermopile. And when that happens, my thermopile will begin to generate its own millivolt circuit. Once that millivolt circuit has been established, I need to wire in thermostat. So I'm going to come out. Actually, I'm going to change. Let's take care of one thing here. I want to go on the other side just for the sake of easiness. I'm going to come and I'm going to wire up my thermostat. Come out of my Thermopile. I'm going to come up into my R. Okay, out of my R, I'm going to go to my W. Okay, my W, just for my sake, I'm just changing colors here. We're going to go to W. Out of my W, I'm going to come down to my high limit switch. My high limit switch is a safety. In the event that my furnace gets too hot, I want it to be able to shut off my furnace. I'm going to come out of my high limit switch, and I'm going to wire in my main valve. Okay, out of my main valve, I'm going to go right back to my thermal pile, just like this. Okay, so what about my pilot valve? What do I got to do there? I'm just doing the same thing, man. All it is just two valves or two coils wired in parallel. So I'm going to come here, and it's going to also come to my pilot valve. And I'm just going to come right back. And down. So once this pilot valve is actually energized, you will see in this circuit that once a flame is actually established here, and I'm going to kind of draw a little flame here. All right, here's a little flame. Here we're going to use a little orange here, right? Here's a little flame, right? That flame is touching that thermal cup, that Thermopile. When that flame begins to heat up that Thermopile, it is now going to generate a millivolt circuit. That millivolt circuit is enough to energize this coil, which will keep the pilot valve energized and keep that pilot flame burning throughout the entire operation of this piece of equipment. The only way that that pilot flame or that pilot valve will ever de-energize is if that pilot flame blows out or gets defective or what have you. That's the only way it will ever shut off. And when that does, that pilot coil will de-energize and eventually shut off. But as we are doing this, that valve is going to be energized. Okay, so there's my flame. That flame heats up that pilot, that Thermopile. That Thermopile is now going to generate anywhere between 30 millivolts and above. Maybe up as high as 350 millivolts. And when that happens, my pilot valve will begin to energize and stay open, keeping the pilot valve open all the time. The other half of this circuit is now through my controls. When my thermostat gets energized, because it is being powered as well in parallel with my pilot valve, I am now able to energize my main valve through my circuitry. My R, thermostat closes, energizes my W, which is my heating, comes down into my high limit switch, which is a normally closed thermostat. Again, it's a safety. It's only going to open if the furnace gets too hot, probably somewhere around 200 degrees. And then it's just going to send it to my main main valve where I will now ignite my main burners, where I can now begin to heat up my space at about 140, maybe 150 degrees. My fan limit switch on my side there will now close, and it will now turn on my blower so I can now deliver that hot air into the space. And that's how you wire a Thermopile standing pilot furnace.